To understand the survival of Indian agriculture, you have to look at the perfect scenario. For hundreds of millions of farmers across the subcontinent, everything hinges on the arrival of rain over fields under ideal conditions, just like this. We measured this survival using a specific baseline. This chart tracks the long period average, or LPA. To maintain stability, India needs to hit this 87-centimeter target between June and September. That specific volume of water dictates the success of the Kharif crop, the primary summer harvest. Roughly 60% of the nation's farmers rely entirely on this summer rainfall to produce their yield. For the last 2 years, the country actually beat the odds. The monsoons delivered above normal rainfall, padding reservoirs and creating a comfortable buffer for the agricultural sector. This 87-centimeter baseline represents the slim margin of error for India's food security. Any deviation from this average immediately strains the systems that keep the country fed. Now, that comfortable streak is ending. The India Meteorological Department has officially issued a forecast for a below-normal monsoon season. Their projections expect the total rainfall to reach only 92% of that crucial long-period average. That number sits dangerously close to the edge. The official threshold for declaring drought conditions is any drop below 90%. A 2% margin is all that separates a difficult year from a widespread agricultural crisis. But the source of those dry skies isn't over India. To find what's stealing the rain, we have to look thousands of miles away, straight across the open ocean. Predicting the fate of this year's harvest means decoding an invisible temperature anomaly currently developing in the Pacific. This map displays sea surface temperature anomalies. The dark red band stretching across the eastern and central Pacific shows an abnormal warming of the water, the classic signature of El Niño. In a typical year, strong equatorial trade winds blow steadily from east to west, pushing warm surface water toward Asia. El Niño disrupts this. Those trade winds lose their strength, allowing that massive pool of warm Pacific water to slide eastward, back toward the Americas. That moving heat rewires the Walker circulation, an east-west atmospheric loop where air rises over warm water and sinks over cool. As warm water shifts east, it drags the storm-producing air currents with it, dropping a column of dry, sinking air over the Indian Ocean. It operates like a long-distance vacuum. The Pacific Ocean essentially siphons away the atmospheric mechanics required to build rain clouds over the subcontinent. Fortunately, the monsoon is rarely dictated by El Niño alone. The atmosphere is a chaotic system of overlapping forces, and right now, two distinct factors are fighting back. The first is a positive Indian Ocean dipole. This creates a temperature imbalance right in India's backyard, warming the western Indian Ocean and actively trying to pull moisture back toward the mainland. The second factor lies far to the north. Lower than average snow cover across Eurasia heats the land mass faster, strengthening the thermal pressure system that draws summer rain into India. The final amount of rain that actually falls won't follow a straight line. It will be the result of a brutal global tug-of-war between the Pacific trying to suppress the storms and local thermal drivers trying to build them. If El Niño wins out and that 92% projection holds, the physical deficit hits the ground fast. The first domino is the harvest itself. Lower Kharif yields mean farmers have less to sell, directly reducing rural incomes and stripping away consumption demand across half the country. Next, the structural reserves start to fail. Without that critical volume of water soaking into the earth, groundwater recharge slows to a crawl, placing immediate stress on local drinking water supplies. Falling reservoir levels translate directly into power shortages. When the water stops flowing, the nation's hydropower capacity drops, leaving the energy grid vulnerable. A weak monsoon breaks out of the agricultural sector almost instantly. It cascades into a compound failure of national energy and water infrastructure. That structural failure ultimately travels from those dried-up rural reservoirs straight into the urban economy. Reduced agricultural output inevitably hits the markets, creating immediate localized food scarcity. When the supply of basic staples drops, grocery prices spike. This localized scarcity rapidly translates into rising food costs, driving up the broader national inflation rate. And managing this chain reaction is becoming harder. Rising global temperatures are actively increasing the variability of these climate drivers, making dry spells more extreme and rainfall patterns highly erratic. We are looking at a system where a slight warming in the Central Pacific Ocean can stall Indian power grids and inflate grocery bills in New Delhi. In a heavily interconnected climate, tracing these ocean patterns is required to protect the economic survival of over 1 billion people.